Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In my last lecture, we have learned how to find derivatives of parametric functions. We also did some questions from exercise 5.6 of your textbook. Now, today, we will find derivatives of two important parametric functions which are frequently asked in board exams. And first one is, if x and y are connected parametrically by equations without eliminating the parameter, find dy by dx. Here x is equal to a times cos t plus log of tan of t by 2, and y is equal to a times sine of t. Here t is the parameter. Now to find dy by dx, we have to find dy by dt and dx by dt. Now for dy by dt, we have to differentiate y with respect to t. We get dy by dt as a is constant and differentiation of sine t is cos t. So dy by dt is equal to a times cos t. Now we calculate dx by dt. X is equal to a times cos t plus log of tan of t by 2, and differentiation of cos t is equal to minus sine t, and differentiation of log of tan t by 2 is 1 by tan t by 2. Then differentiation of tan t by 2 is secant square t by 2. Then we have to again differentiate t by 2, and differentiation of t by 2 is 1 by 2. Now we can write 1 by tan of t by 2 is equal to cot of t by 2, and secant square t by 2 is equal to 1 by cos square t by 2. Further, cot t by 2 is equal to cos t by 2 divided by sin t by 2. Thus dx by dt is equal to a times minus sin t plus 1 by twice sin t by 2 cos t by 2. We know that sin 2 alpha is equal to twice sin alpha cos alpha. On replacing alpha by t by 2, we get dx by dt is equal to a times minus sin t plus 1 by sin t. That is further equal to a times minus sin square t plus 1 divided by sin t, and 1 minus sin square t is equal to cos square t. Therefore dx by dt is equal to a times cos square t divided by sin t. Now we can write dy by dx is equal to dy by dt divided by dx by dt. That is equal to a cos t divided by a cos square t divided by sin t, and that is further equal to a cos t into sin t divided by a cos t into cos t, which is further equal to sin t divided by cos t, and that is equal to tan t. This completes question first. Now let's take second question. That is, if x is equal to under root of a raised power sine inverse t, and y is equal to under root of a raised power cos inverse t, here t is the parameter, and we have to show dy by dx is equal to minus times y by x. Let us first find dy by dt. That is, we have to differentiate y with respect to t. We know that differentiation of root of fx is equal to 1 by twice under root of fx into f dash x. Thus differentiation of root of a raised power cos inverse t is equal to 1 by twice under root of a raised power cos inverse t. Then differentiation of a raised power cos inverse t. Now, differentiation of a raised power fx is equal to a raised power fx log of a into differentiation of fx. Thus, differentiation of a raised power cos inverse t is equal to a raised power cos inverse t log of a differentiation of cos inverse t, and differentiation of cos inverse t is equal to minus 1 by under root of 1 minus t square. Thus, dy by dt is equal to minus times a raised power cos inverse t log of a divided by 2 times under root of a raised power cos inverse t into under root of 1 minus t square. Now we will calculate dx by dt. X is equal to under root of a raised power sine inverse t. So differentiation of under root of a raised power sine inverse t is equal to 1 by twice under root of a raised power sine inverse t into differentiation of a raised power sine inverse t, and differentiation of a raised power sine inverse t is a raised power sine inverse t into log of a into differentiation of sine inverse t, and differentiation of sine inverse t is equal to 1 by under root of 1 minus t square. Thus, dx by dt is equal to under root of a raised power sine inverse t into log of a divided by 2 into under root of 1 minus t square. Thus, for dy by dx, we substitute dy by dt and dx by dt to get dy by dx. Now, on simplifying this, we get dy by dx is equal to minus times under root of a raised power cos inverse t divided by under root of a raised power sine inverse t. But we know that under root of a raised power cos inverse t is equal to y, and under root of a raised power sine inverse t is equal to x. Thus, dy by dx is equal to minus y by x. That proves the result. In this way, we have completed differentiation of parametric functions, and in my next lecture, we will learn some new concepts. Till then, take care of yourself. Thank you.